Okay, welcome to Unit 4 on Conservation of Energy. This is Lesson 4, Elastic Potential Energy and Energy Conversions, and this is the second example problem. This example problem doesn't really include very much math. This is more of a concept-based lesson, and we're just going to be talking through what energy transformation take place at different time periods in an object being launched up a ramp and then into some water. So I've sketched out the scenario here on the page, and essentially what's happening is we have some sort of very large mass or solid piece with a spring attached to it, and the spring is all coiled up at the beginning, and we're going to release the spring, and it's going to push this block or this mass off the ramp, and it's going to continue upward for a while until it runs out of y velocity or energy in the y direction. And then it's going to plummet into the water and splash. There's 4 steps that the workbook is asking you to identify what energy conversions are taking place. So in step number 1, we have the release of the spring, and the mass is going to move up the ramp. So in step number 1, we have energy stored in the spring, and it's going to be transferred into the block. It's going to be transferred into the block into kinetic energy and potential energy due to gravity. So here I'm going to write energy spring from the spring is transferred to or transfers to kinetic energy and potential energy due to gravity in the block. Okay. Fairly straightforward. So that's going to cause this to rise up here. Then it's asking us, once this leaves the ramp and it continues upwards, from basically, well, I think they're asking sort of from here to here, up to the max height. So this is our max height. And it's asking us what energy conversions are happening there. Well, this object has some Y kinetic energy, and it's being converted into potential energy. Keep in mind, if there's no air resistance, this thing's x velocity is going to maintain the same rate. So in the y direction, I'm going to say that kinetic energy of this object, I'll just say kinetic energy transfers into potential energy due to gravity in the block. Alright, and I'm going to put a little disclaimer in brackets here. I'm going to say until it reaches the peak. Okay. Number 2. So then finally, number 3 here, not finally, but almost finally, this block is going to start plummeting down towards the water. So step 3, we're going to have some more potential to kinetic energy transformations. And really what's going to happen is at the peak, in the y direction anyways, this block is entirely potential energy in the y direction. So it's going to start falling again, and as it falls, it is going to convert its energy back into kinetic energy, or energy having to do with motion. So here I can say energy potential due to gravity is converted to, or in the block, is converted to energy kinetic in the block. I could say as it falls as well, I guess. As it falls. Alright. Then finally, this block is going to splash into the water, and there's going to be a number of energy conversions that take place here. So essentially, when it's at water level, when it's at the bottom level here, this block isn't going to have any potential energy left. It's going to be entirely transformed into kinetic energy. So we can say that the kinetic energy of the block is converted into, there's a couple here. You can imagine all the energies that are going to be released as water splashes. So I'll say maybe some sound energy, because it's going to make this splash sound. So sound energy from water or from collision. We can say that maybe there will be some energy in the form of waves in the water, so maybe wave energy. We can call that kinetic energy. So kinetic energy in energy in the water. You can really come up with any array of different energies here. We could also say there's probably a small amount of heat energy as well. Of heat energy, because there's going to be some friction here. Okay. You could probably come up with a few more energy types for number 4 if you were so inclined, but really I think this, in summary, is essentially what this question is looking for. Alright, that's all.